All right, so in question number 2, here are the similarities that hopefully you can draw from. P, we already said, was the initial value of 2000, and in case it was curious to you why we would use the letter P for something called an initial value, it's because in the world of banking, we call that the principal investment or the principal value. So the letter P is actually a banking letter more than a math letter, but we use P in the banking world to describe how much you initially invested into an account. We call it your principal investment. Now, some of these you might have just picked up in a similarly common sense kind of way because you noticed where the numbers were. Or you sort of picked up on context clues and thought, well, surely they're using that letter for a reason. Like, for example, T. T naturally stands for time. And in a question like this, T could have very easily been our 20-year span of time. So if you picked up on that sort of naturally, again, that one was meant to capitalize on your sensibilities that you may have already just had ingrained. R and N are not quite as straightforward, but perhaps now that we know T is time, we can discern something about N. Take a look at where the letter N appears. It appears twice in the formula, but the part that's catching my eye is the part up here in the exponent. Because I remember when I was writing my answer to number 1, I was mentioning that time, which in this case was the 20 years, was being measured in quarters, and 4 was the number of quarters per year. And it was that frequency, the fact that we were doing this 4 times a year, that we had to think about, because it wasn't just 20 that we were plugging into the equation, it was 80, because we were doing something 4 times a year for 20 years. So that extra 4 is actually what we refer to as the N, and N represents the frequency of the investment. Frequency is essentially how many times a year does anything happen. So I'll just write that parenthetically there, per year. If the investment is quarterly, it happens 4 times a year. So we say N is 4. If the investment is, say, monthly, then N would be 12 times a year. If the investment is annual, it happens once a year, so N would be 1. And it's just worth noting that when we use that word frequency, we're just really saying how many times a year is the bank going to kick you down some interest. If it's quarterly, that's 4 times a year. Monthly, that's 12 times a year. Annually, that's 1 time a year. It's just how often is the bank going to kick you that interest payment. Now, the only other thing we haven't talked about yet is the letter R, because R appears to be part of a fraction, and that might be kind of tricky to think about as well. So perhaps it might help if at this point I plug in what I see so that I can visualize what R might represent. P we already said was 2000, so I'm going to plug that in. Then we have 1 plus, I don't know what that 1 is for, it's just part of the formula, and then a fraction. R we don't know, over N, which is 4, to the power of 4 as my frequency times 20 as my number of years. That's what this formula looks like so far with all the different pieces plugged in. So now I'm going to ask myself, okay, let's not start from scratch here. We got this expression in number 1. We did it. We know that it works. How could we translate it and match it to this formulaic structure? In other words, what were we dividing by 4? Why would we ever have been dividing by 4? Let's think about that. Number 1, why would we have divided by 4? Oh, it's right here. We divided by 4 because we were taking the percentage interest rate, the 8% annual rate, and dividing it into 4 smaller payments. So it seems as though R must represent the rate that we were dividing up. So R must be the rate. Now, here's one thing to think about though. If R was 8, then mathematically this doesn't make sense. This doesn't match what I have as my answer for number 1. Because 8 divided by 4 is 2. 1 plus 2 is 3, and we know the multiplier is not 3. That doesn't make any sense. So I need to look at this. Was 8 really the number that I plugged in for R? Was 8 really the rate? Go back. 8 was the percentage, but oh, If none of these numbers in the question are percentages, I need a like term, a compatible term that I can plug in. I probably wasn't plugging in 8. I was probably plugging in 8 as a decimal. Because if 8 is a percentage and none of these are percentage numbers, there's no way that would have been compatible. But a decimal could have been. If I move the decimal over 2 places, 1, 2, then I would have gotten 0.08. And let's see if that mathematically works out. 0.08 divided by 4, I'm going to do this in a calculator just to be extra safe. 0.08 divided by 4 is 0.02. 1 plus 0.02 is 1.02, and yep, that is the multiplier that we already thought. So as it turns out, the rate is the percentage that they gave us, just written as a decimal. So it does seem like this formula makes sense. It does seem like this formula actually has much to do with all the thoughts we were already having. We just had to make sure that we kind of broke down those thoughts in slightly different ways. Now that you've seen this formula, though, you may want to highlight it or do something that jumps out to you, because this, in general, is a compound interest formula that works for all types of interest payments. And that means it works for things like quarterly, it works for annually, it works for monthly, it works for even ridiculous things that are probably never going to happen, like daily interest and stuff like that. But it may be worth putting into your notes, especially if you keep notes on, say, like the front page of the packet, if you printed it out, because this compound interest formula works for any sort of compounding where you know how frequently it's going to happen. N tells you how frequently it's going to happen. So compounding quarterly, compounding monthly, compounding annually, compounding daily, compounding semi-annually, that's twice a year. Those would all qualify as candidates for the compound interest formula. Now, you don't have to use the compound interest formula. We did question number 1 without the formula and we were just fine. But this is another way of plugging in all of the numbers from a word problem so that you can get your calculator to do the heavy lifting. It's just another way of doing number 1. Once you've seen how this formula works, take some time to make sure you understand all its components, because we're going to end up using that formula for question number 3.